Okay, dear students, we will see what are the definition of independence, dimension, and basis. Here, for independence, the vectors columns of a matrix A, the vectors which are columns of the matrix A are said to be independent only when its null space is equal to zero vector. Null space is, we denote null space by n of A. Therefore, that is n of A is equal to 0. 0 vector. 0 vector looks like 0, 0. If not 0 vector, the null space is not equal to 0. That is, the null space n of A not equal to 0, then we say that vectors are linearly dependent. Linearly dependent vector. Okay, the independence. Next, dimension of this space. Here we consider the rank of that matrix A as a dimension of the matrix A. Okay. Basis, the columns that contains pivot. The column contains pivot in echelon form U after reducing that matrix to echelon form. That columns that contain pivot elements are the basis for the column space. The corresponding columns in the given matrix forms a basis. Forms basis for the space. So now we will solve the problem on dimension and to find the dimension and basis for the given matrix. The given matrix is, which is A equals 1, 2, 0, 1, 0, 1, 1, 0, 1, 2, 0, 1. Therefore, we have already know that dimension of this matrix, which is equals to rank of that matrix A. Okay. Then the basis is the number of pivot elements in the row reduced echelon form. The number of pivot columns in the row reduced echelon form forms a basis. Okay. Number of basis is equal to number of columns contains pivot in row reduced echelon form. In row reduced echelon form in the matrix U. In the matrix U means row reduced echelon form forms a basis. You know that already know dimension of rank. To find the ranks of this given matrix, you have to reduce this matrix to upper triangular matrix or by using row reduced echelon form. We use the rank of that matrix. So that matrix to find here in first row leading entry is 1. Therefore, there is no change in the first row. And in second row, below that leading entry non-zero element, in second row we may already 0 is here. Therefore, and this one is non-zero. Therefore, there is no change in the second row. We may change in the row 2. In the row 2, we use operation to make this 0, and this is pivot element. To make this 0, we use operation R1, R3. We are making R3 as R3 minus R1. We are subtracting row 3 from the row 1. Okay? But the matrix is, resultant matrix is, first row as it is 1, 2, 0, 1. Second row as it is 0, 1, 1, 0. In third row, R3 minus R1. 1 minus 1 becomes 0. Here 2 minus 2 becomes 0. 0, 0, 0. And 1 minus 1 becomes 0. Therefore, this is the upper triangular matrix. here in third row there is no leading entry. There is no non-zero leading entry. The entire row is containing zero elements. Therefore, here by the use of this matrix, by using this matrix, we find rank of this matrix. Therefore, the rank of the given matrix A is number of non-zero elements in this matrix. Number of non-zero elements. This is non-zero. This is non-zero. This is zero element. Therefore, these two are non-zero elements. Therefore, the rank becomes 2. As well as rank, we already know that dimension of this matrix is also equals to rank of that matrix. Therefore, the dimension of A is also 2. Okay. Here, dimension rank is 2. Therefore, we already find dimension. To find the basis, what is basis? Basis is number of columns contains pivots. Here containing pivot element. Pivot element is 1, non-zero element. And here pivot element is this. Here pivot element is leading entry non-zero. This is pivot element in the first row. Pivot element in the second row. The first column, second column. And here pivot element is 0. Here pivot element is 0. Therefore, the number of columns contain pivot element is 1. This and this. Therefore, corresponding this column in this matrix forms a basis. Therefore, basis for A is basis for matrix A is basis of A is containing pivot element. Number of columns contains pivot in the matrix U forms a basis. Okay. Here pivot element containing first column containing pivot element and second column containing pivot element, and in third column pivot element is 0. In fourth column also that does not contain pivot element. Therefore, first column, second column contains pivot elements. Corresponding to these columns in the matrix, given matrix 1 0 1 1 0 1 is a 1 basis, and in second column corresponding to second column 2 1 2 forms basis, comma 2 1 2 forms basis. Therefore, these two are basis for the given matrix. Understood? So now we will solve this problem. Previous problem is to find the basis and dimension for the given matrix. This is describe whether the vectors 1 3 2, 2 1 3, 3 2 1 are linearly independent or dependent. We know that linearly independent means the given vectors for the given vectors, the null space of that given matrix. If this matrix using the vectors are columns. So 1 3 2 and 2 1 3 and 3 2 1. This is the matrix A. To check whether these three vectors are linearly dependent or independent, we know that the null space of this matrix is 0. Then we conclude, which implies n of null space is equal to 0. Then we conclude the vectors are linearly independent. Or else the vectors are, if not n of A is not equal to 0, we conclude linearly dependent. The find null space, we have to find null space. What is null space? Null space is a solution for Ax which is equals to 0. Ax which is equals to 0. Here A is a given matrix and X is 3 unknowns. X has 3 unknowns: x1, x2, x3. x1, x2, x3, x1, x2, x3, x1, x2, x3, like that. Then multiply A into x. A is given matrix 1, 2, 3, and 3, 2, 1, and 3, 1, 2. And 2, 3, 1. Here. Okay, A is this. What is n of A? N of A null space is solution for this equation. Solution for this equation. Therefore, we reduce this matrix to U for the purpose of simplification. We reduce this matrix to U. U means we use by using echelon form. We reduce this matrix to U. Then we multiply with this x1, x2, x3 column vector. We get the values x1, x2, x3, and we can easily find the null space. Okay. We reduce this matrix. What is this matrix? Which is in first row, the leading entry is non-zero and as well as 1. In second row, we make below that pivot element, we make these two elements 0. To make these two elements 0, we use operation. R2 dash. We are making use R2 minus. Operation is R2 minus 3 into R1. In row 3, R3 dash, R3 minus 2 into R1. 2 into R1. These are operations. The result matrix is 1, 2, 3, same as it is. And in second row, R2 minus 3 R1. R2, 3 minus 3 into 1, 0. 1 minus 3 into 2. 1 minus 3 into 2. 1 minus 6 gives minus 5. And 2 into 3 into 3. So 2 minus 9 gives minus 7. In row 3, in third row, is operation R3 minus 2 into R1. R3, 2 minus 2 into R1 gives 0. And R3, 3 minus 2 into R1. 2 into 2, 4. 3 minus 4, minus 1. And R3 minus 2 into R1. 1 minus 2 into 3, 6. 1 minus 6 gives minus 5. We are making below the first pivot element, they are making other element 0. In the second step, if this is pivot element, we make this as 0. We make this element as 0. To make that element 0, we use operation for third row, that is R3. We are making R3 dash is equal to R3 minus R2 by 5. R2 by 5 or R2 by 5. Okay. R2 by minus 5. R2 by minus 5. R3 minus R2 by minus 5. We make then we get R3 minus R2 by minus 5. R2 by 5. R2 by 5. R3 minus R2 by 5. Then we get resultant matrix is 1, 2, 3, 0, minus 5, minus 7, 0. Then R3 is minus 1 minus R2 by 5. R2 is minus 5 by 5. Minus into minus plus. 5 get cancelled. Minus into minus plus. Therefore, minus 1 plus 1 gives 0. Yes. Then R3 minus R2 by 5. R3 is minus 5 minus R2 is minus 7 by 5 gives minus 5 plus 7 by 20 minus 25 plus 7 by 5 minus 25 plus 7 minus 18 by 5 minus 18 by 5. To make this, we use to make this one pivot element and this one, we make use operation, and also make this one, we use operation R2 dash is equals to R2 minus R2 by minus 5. R2 by minus 5. Then in R3 dash is equal to R3 by minus 18 by 5. Then the resultant matrix is R2 by 5 gives 1, 2, 3, 0, here 1 and 7 by 5. R2 by 5 means R2 is minus 7, then minus 5, minus get cancelled, then 7 by 5. Here 0, 0 as it is, and R3 by minus 18 by 5. R3 by minus 18 by 5 means R3 into 5 by minus 18 gives 1. Therefore, all columns having pivot elements, here 1, 2, 3. In first row, 1 is the pivot element. In second row, this is the pivot element. In third row, this is the pivot element. Therefore, we multiply this matrix with this matrix with this vector matrix, column vector matrix. U, this matrix, we call this matrix as U. Therefore, U x which is equal to 0. U is 1, 2, 3, 1, 2, 3, 0, 1, 7 by 5, 0, 0, 1 into x1, x2, x3 which is equals to 0, 0, 0. To find null space, we multiply these two matrices, we get 1 x1 plus 2 x2 plus 3 x3 which is equals to 0. First row with this column, and then second row with this column. Then we get x2 plus 7 by 5 x3 which is equals to 0. In third row, 0 into x1, 0 into x3, and 1 into x. 0 into x1, 0 into x2, 1 into x3. We get x3 is equal to 0. By using x3 is equal to 0, here we get x2 is equal to minus 7 by 5 x3. Therefore, x2 is also minus 7 by 7 by 5 minus into 0, we get x2 is equal to 0. By using x2 and x3 values in this equation, we get x1 plus 2 into x2 is 0 plus 3 into x3 is 0 which is equal to 0. Therefore, x1 is also 0. Therefore, the null space n of A is x1, x2, x3 which is equal to, here x1 is 0 and x2 is 0 and x3 is also 0. x1, x2, x3. Therefore, the null space is a zero vector. What is vector 0? The vector containing zeros, all elements zeros. Therefore, null space is 0. Then the given vectors are linearly independent vectors. We already know that. We know that n of a is 0. Then the given vectors are vectors. These vectors are linearly independent. This is the problem. And further, we also find here the rank of matrix by using this matrix. Here rank is number of non-zero rows. Here number of non-zero rows is 1, 2, 3. Number of non-zero rows is rank is 3. Therefore, rank of the given matrix A is 3. Rank is 3. If rank is 3, then dimension is also 3. Dimension of that matrix is also. Okay? Understood? This is the problem for determining whether the given vectors are linearly dependent or independent.